Okay, I'm starting again. It's an introduction to design of experiment. We'll call that as a DOE. Okay, so whenever you're creating any new process, okay, the design of experiment is very, very important, especially in the production side of it. Okay, the systematic intentional change to input variable in order to measure impact of the output variable. See, what is a design of experiment is going to do? For example, I need one output. So I should understand how my input should be there. Based on some, I'm making some changes in my input, and based on that, I can see my output variable. Okay, that's what the design of experiment is going to do. See, what we are going to do is identify which variable really has the most impact in the process. See, what we are doing here is we will consider one particular example. See, for example, we'll take a lab, okay, CRL. Okay, in the CRL, I am getting, for example, I'm getting 100 charges, okay, this month. In that 100 charges, if I know that I'm not going to get paid for Medicaid, what you can do, you can stop the Medicaid. So by doing that change in the Medicaid and the input level, I know what is my output, how I'm going to get it in the output, right? That it is defining, saying that what is the design of experiments. Okay, and the screening, so the type of experiment, what all the type it is there, screening, optimization, and then robustness of the experiment. See, in the screening, what we are doing is we'll take a multiple input variable. See, for example, what we need to do, we'll take the same CRL example. Okay, I have an input for the 3 particular pair. So I have to review, okay, which input giving me the better output. Okay, that's a multiple input variable I'll take. And then goal to reduce a number of factors involved in the process. Those key factor make a difference. See, for example, as I told you, I have 3 payers. Okay, one is Medicaid, which I am not at all able to collect, and second one is BCBS, okay, where I am out of network, and third one is Medicare. So what I need to do, what changes I have to do, I know very well if I bill Medicare this time, I may get the payment exactly. So what I need to do when I'm doing experiment, I'll make sure that all my Medicare claims are filed correctly, okay, on time, so that what will happen, my input flow is going smoothly, so that I'll get output of the revenue on time. And second priority, I'm going to give it for BCBS, but since it is a out of network, I know very well it need around 2 level of appeal, and then I'm going to get it. So I'll keep that as a second level of movement. And third one is Medicaid. I know very well I'm not par, I'm not going to collect anything out of it. So this is called screening experiment. By seeing the account itself, you will identify what is a priority 1, priority 2, and priority 3 to finalize what we are going to do. And the third one is optimizational experiment. Here, optimize the factor that are left to ensure that we reach the desired output. See here, we take the same example, Medicaid, BCBS, and Medicare. What you need to optimize? Which insurance you have to optimize? Hello, everyone is there or not? Hello?
Yes, sir, except like Medicaid, right?
No, what, yeah, the 3 we have, okay, Medicaid, BCBS, and Medicare. So if you want to optimize, which input you should get more? As of this practice, only Medicare is paying better, right? Compared to out of network and non-par. So for the optimization, we have to concentrate on the paid insurance, and we have to maximize that. Okay, see, optimize the factor. For example, I'm taking Medicare, and are left to ensure that we reach the desired output. So you have to talk to the client and make sure that all your samples are going towards the Medicare. Okay, adjust those different factor levels. See, for example, some of the factors, Medicaid, we know that if we're not at all going to pay, so what is the purpose of taking it? Okay, we have to ask them to remove that particular account so that the optimization can be reached. And the robustness in the experiment, say for example, we have multiple die structure. Okay, we have a multiple die created, and which one process is giving a better design. See, for example, this is also known as a confirmation experiment, and redesign process is robust. Okay, so what we need to do is, for example, I want one particular design. In that design, we will go back and then check it how best we can do by creating that particular experiment. See, this is nothing but, for example, I have a 3 die. Okay, I'm trying to make the product from out of that 3 die, which is giving a better output without the error. We will take it that as a forward, and then we will work on that. That's the way it should go forward. Okay, And there are types of experiment design. One is one factor at a time. Okay, we'll call it as a OFAT. For example, what we need to do is we will take an input scenario. In that, only one factor you have to understand or analyze on the time. See, for example, I have 12 insurances at a time. Okay, so I'll keep one insurance. For example, I'm reducing this insurance or increasing this insurance charge, whether my payment is increasing or not. That we have to classify. And full factorial is nothing but the entire, for example, 8 pair I'm taking into account. Fractional factorial, for example, instead of 8 I'm taking 4. You got the point, right? For example, 8 pair I have. First one is I'll take one pair and then check, is there, what is the output variable? One pair, is it increasing or decreasing in the charge? Is it going to affect my output or not? That is one. Full factorial, for example, I'm taking all my pair and then checking it whether the output is differing or not. Third one is, for example, I'm taking only four insurance and I'm checking it. So this is a 3 method. Based on that, we come to understand which input file is going to create a major impact on the output. Okay, this is called the output DOE experiments. What is the benefit of here? Here, see here, by doing this DOE, you can check the multiple factor. See, but mainly you can implement that into your charge. Okay, what type of charge you need to get a better output. Okay, and very effective, and then it's a cost effective because we can do one factor at a time to understand. Okay, enable to analyze a large amount of data and construct the prediction model. Okay, large amount of data can be checked and then we can close from there. Okay, and the process of conducting the DOE. See how we are going to conduct the DOE. Okay, identify the objective in using the experiments. Okay, what are all the experiment we are going to do here, and define what is measured to show the result of the experiments. Okay, these are all just general. Okay, so when you are going to do any DOE experiment, you have to understand what is your input, what are all the things you are going to identify in that particular input, and how you are going to take it forward. Okay, that's what I'm trying to explain here. Okay, identify the factors that are controlled during the experiment. That's what the one factor experiment, right? Only one factor we will input file and we will see how the output is changing. Okay, that is one. And set of levels that experiment must be considered. Okay, and consider how many experiment we are going to do and how we are going to conduct it. It's nothing, very simple. If you have the mini tab, you can input all your inputs and then it will give an output saying that what all the factors is going to affect your output. It's a very simple exercise if you have a mini tab. Okay, and the analysis, it will give a clear cut analysis. For example, I'm uploading 8 claim. Okay, eight pair input, and then I'm comparing with my collections. Okay, this mini tab will clearly tell you out of your output. Okay, this 3 pair is major impact on your output. Like that, it can give a material or it can give the analysis. Okay, and then based on the analysis, you work on the analysis. For example, I identified only 3 major pair, I'm getting a better collection. So what I need to do, I focus on that 3 instead of concentrating on unnecessarily on all the pair. Okay, where I'm not going to get money, I don't want to concentrate. I'll focus all my concentration towards what I can collect. Got it?
Yes, sir.
Right. Okay, I think we have
Sir, and the robustness experiment மட்டும் மறுபடியும் சொல்றேன்.
Robustness experiment on the it's related to the production flow. Okay, see, for example, I'm creating a 3 die. Okay, so 3 type of product. See, for example, I'm going to create one water bottle. Okay, in that I'm creating a 3 different type of method. Okay, production method. Which method give me very effective way? That's called your robustness experiment. It's not useful for our process usually, because we are not able to compare, right? If you want to compare robustness also, you can compare by the people only, because we don't have a machine or a die, right? You have 3 user in your team. Okay, for example, you are giving a charge entry to the 3 people. Okay, you can consider them as a production method or methods. Okay, who is giving a better results without getting any denial, or how fast I'm getting a payment when these 3 users are entering. Like that you can compare, but robustness is similar to the production flow only. Okay, so for example, I'll have a 3 die or 3 process. I know that one process is giving better results, then I can avoid these 2, or I can improve on the process. I can redesign the process. Okay, that's the way the robustness will work. Clear?
Yes, sir. So, but like when we மறுபடியும் டை பண்ணும்போது, I mean,
I'll all the
பண்ணலாம் அப்படிங்கிற மாதிரி.
கரெக்ட். எல்லாம் இப்போ என்னெல்லாம் டிஃபெக்ட் இருந்தோ அதை கொண்டு வந்து நான் புது டைல வச்சுட்டு, ஆர் the புது ப்ராசஸ்ல வச்சுட்டு I'll streamline it.
Okay, sir.
Okay, and the robustness experiment, it's based on one method. Okay, which method is very effective, that we'll identify, and then based on that we have to work on. Okay, right. Anyone joined after that? That's all right. Our strength is today. Okay, can we close by this? Because I have some other topics which is very important one. Okay, the cycle time reduction is all very good topic. I don't want to miss anything. So we'll do one thing. We'll stop our class by this. I'll continue this DOE by next class. Okay, so that here also something, but DOE this not very important, but other topics are very important. Okay, cycle time reduction and other things are very important. I thought of covering this. So we'll do one thing. With that, we will close this today's topic, and we'll continue this from next week onwards. Okay.
Sure, Eric.
This mainly due to our poor strength today. So next week, don't miss. Okay, we'll have a lot of new topics. Okay.
Okay, Eric.
Okay. Okay. Thanks, everyone.
Thank you,
Take
Eric.
care.
Thank you, everyone.
Yeah, I
Bye.
check the link. Okay, what I put it in the message. Okay, you can go on and see all your old one. Okay, one day is pending. I'll upload that also today. Okay.
Okay, Eric. Thanks,
Okay.
Eric.
Thanks, everyone. Bye.